Welcome to Breadboarding. This is video 42 in the Breadboard PC series, and this is a follow-on from the previous videos where we've been looking to convert the floppy disk controller from DMA, direct memory access, to PIO. Now in the previous video there were a couple of things left over, so the real-time clock that I did in video 39 wasn't working, and the software that we were looking at was fairly dull. So in this video we're going to be looking at slightly more interesting software, so I'm going to look at the Zork I Infocom adventure game and Norton Utilities and Norton File Editor. So as I said, the previous two videos we converted the floppy disk controller to use programmed IO, so that means it's controlled by the CPU rather than by dedicated DMA hardware. But during the previous video I'd noticed that the real-time clock wasn't working. Now this actually turned out to be pretty straightforward. What I'd forgotten to do is to copy some of the configuration items over in the copy of the BIOS that I did for the programmed IO, and in fact this config file basically just needed to have the real-time clock and real-time clock non-volatile RAMs, the CMOS, being added to it. So once those two lines are added and I reassembled and reprogram the BIOS, then that was working. So if you have a quick look at powering on the nanocomp, and we'll see that now we can get access to the real-time clock configuration. So let's power it on. And as we start the BIOS, I'm just going to press F1 to go into the setup utility. Okay, and if we go into full screen, it'll just make it a little bit easier to see. So you can see here that the real-time clock about halfway up the screen there, 2024 0808, so it's the 8th of August 1657, so that's pretty close to the current time. So that seems to be working. We just print out the configuration. We can see that we've also disabled the memory test, and we're not scanning for any extra BIOS extensions at the moment. But what we can see here is the floppy disk drive. We haven't got a floppy disk drive configured here, so we just need to go in and to configure this. So you'll see here that we can change the first floppy drive, and if we look at the help here, we set this to 4, and if we look at the second floppy drive, we need to set that to 0. We print out the configuration, so you can now see we've got the time. Drive 0 is 1.4 meg and drive 1 is none. We're not scanning for BIOS extensions, and the memory test is disabled. So we're just going to write that, and then we'll just put the boot disk in, and we'll see whether or not it comes up in MS-DOS 3.3. Okay, so the current date is coming up, so that was previously coming up as I think the 1st of January 1980, so that's correct, and the time is also correct as well. So it looks like certainly with MS-DOS 3.3 upwards, then the real-time clock is working. PC-DOS 2.10, I don't think the date works because it didn't know about dates at that point in time. So now in MS-DOS 3.3, now previously we just had the very basic files, so what I've done here is I've added some more to this. So we've got the full DOS, we've also got Norton Utilities, Zork and Norton Editor. So the key thing I've needed to do is reformatting all of the MS-DOS disks on the disk drive that I'm using in the Breadboard PC. So I've got another PC I can use with this same drive plugged into that, and that really seems to make a big difference. Now, one of the reasons why floppy disks fell out of use is they're quite unreliable, and already some of the disks I've been using have got bad sectors and things on them. So really the sooner I can move away from using floppy disks onto hard drive, then the better. So I'm going to sort of really focus to try and get onto the ID hard disks over the coming week. So now we've got our full MS-DOS 3.30 with Norton Utilities and Norton Editor. And I've also managed to come across the Lost Treasures of Infocom from 1991 and the Zork I text adventure game, one of the very early text adventures. So I've actually managed to get that up and running. Now normally Zork and the Infocom adventures require the anti.sys config.sys driver. Now I did have a problem with that, trying to get that working. Some of the video handling wasn't quite right. But what I did find out is in the setup.inf file, which actually sits in the folder with Zork, that there are a couple of characters in here. The P indicates 80 columns, J25, and then by default it's set to Y, which means enable ANSI codes, but by setting this to N, then we just get ASCII. And you'll see when we go into the Zork that it will look pretty much okay. I think when you exit it, you still get one anti-code, I think, still appears, but it basically means that it's quite clean. So this is the box of Lost Treasures of Infocom, and it even includes the Zork I map. So this includes a full map if you don't want to go through working out where everything is, then there's even a full map in there. So I'm going to be going into that in a few minutes. So let's take a look first of all, looking at Norton Utilities. Now Norton Utilities is downloaded from WinWorld. I think there's a lot of software, old legacy software up on WinWorld. Okay, so we're in Norton. It's running in monochrome display adapter mode. So if we just look at disk information, first of all, you can see the disk usage, and if there's any bad blocks, then they'll come up as B on here. And some of the other disks I was working with have actually got a number of bad sectors. So I've stopped using those, and so I'm going to try and switch over to use the hard drive as soon as possible. And then it also gives them some useful technical information. So it tells us a double-sided, high density, quad density, 18 sectors per track, and we have each sector is 512 bytes. Tracks are made up of 18 sectors per side. There are 2 disk sides, and the disk is made up of 80 tracks. But given that we've got 2,847 clusters for 1.4 megs, then I think these clusters are actually 512 bytes. And then it also tells us that the disk's root directory can hold 224 files. If we're using older versions of DOS, so PC-DOS 210, then the root folder there with the smaller disks couldn't hold quite so many files. Now, probably one of the more interesting things in this, you can actually use this as a disk file editor, so you can actually modify the disk. And in particular, one of the more interesting areas of this is looking at the boot sector. So if we choose the logical sector 0, 0, then look at the item. So this is showing the boot sector, which is actually used by the BIOS to actually boot up the operating system. And you'll see the EB3490, what that actually is a short jump to 34, and then 90 is in fact the no operation. And in fact, where this is jumping to, the first actual instruction is in fact at FA33, and that's actually where the code executes. The rest of the information above there, you can see there's an MS-DOS 3.3 over on the right hand side here, and you can also see down the bottom there's also all of the various system messages, and you can even see down the bottom, if we switch this into text mode, it's probably a little clearer. If we're in text mode, we can see that you can the various messages, but also it's got the IO.SYS and the MS-DOS.sys down the bottom there, and that's used by the boot sector code in order to work out how to load the operating system. And in fact, what I have done, and I'll go through this in another video another day in a bit more detail. So this file in fact disassembled the boot sector there, and we can actually see here the EB3490. This is, if we just make this a little bigger, you can see this is a short jump to 3.6. So this is where the clear interrupts and everything else. So this area here is known as the BIOS parameter block, and this actually has a lot of the key parameters and things that tells the boot sector and the early parts of the operating system what all the different disk parameters and things are. Then as we go further down, then there's all the code. So I'll go through this in another video, explain how various versions of MS-DOS load. This just means that if we want to, we can inspect these parameters, and if we need to change them, for example, so in particular when dealing with some early versions of MS-DOS that don't support higher disk formats, then there can be some of these parameters we might need to tweak a little to actually get the boot disks and things working. So that's basically the boot sector, and then if we go and perhaps choose the root directory, can then actually go through and have a look at all the directories. And certainly if you'd actually run these disks actually in later versions of Windows, and quite often Windows will put additional hidden folders and undelete recovery folders and things, but this has only been used in an MS-DOS PC, so the directory structure is actually fairly clean. You can see here that not only does it give us the file names, but we've also got the clusters. So these clusters refer to the file allocation table. So Again, I'll go through the way how MS-DOS boots sometime in the future, because in order to diagnose all these floppy disk issues, I've kind of got quite familiar the way how floppy disks work. We can also see here we've got not only the Norton Utilities, but we've also got the Norton Editor folder. So there's a couple of versions of Norton Editor, and in fact the Zork as well. So this allows us to go in and actually have a look. We can look at individual files. So if to choose, for example, a file. So if we choose a file, so for example, IO.SYS is the first bit of the operating system that gets loaded. We have a look at this, then we can actually see the detail of what's in here. So what this allows you to do is to check that when you're actually reading the data off the disks, for example, when I was checking to see what was going on with the floppy disk controller, you can actually check to see what the first couple of bytes at the beginning there and the last couple of bytes at the end of the previous sector were, so that you can see whether or not all the data has been read properly. So quite low level stuff, but very useful. And if you need to, you can actually make changes to the disk as well. So that's Norton Utilities. Have a look at the Norton Editor. So there's two Norton Editors here. There's one which was released very early on, because the basic Edlin that comes with MS-DOS is a little bit basic, or very, very basic. The Norton NCE editor here is the classic editor, which was a very early version. I won't go into that, it's not probably much to look at there. But the full Norton editor is much closer to what you probably know as the MS-DOS 5 editor, very similar to the MS-DOS 5 editor. And you can see here that it's very much got sort of a full menu system, copy and pasting, paragraphs, so the Norton Editor is definitely what I would use if you were needing to do any significant text editing. Certainly Edlin in early versions of MS-DOS was quite tricky to use. So this is Norton Editor version 2 from 1990. So we've got some editors, slightly more interesting software. And then finally what we'll have a look at is Zork. I'm in the wrong folder there. So Zork, the interpreter itself, is only about 11K, and then the game itself is actually contained in the data folder. So Zork 1.dat is about 92K, which I think is it is compressed, it is zipped. So the only thing I needed to do to get this to run cleanly is the setup.inf. By default had a Y on the end of that, and by changing this to an N, then it basically means that it doesn't try and use the anti-escape sequences for doing colouring and cursor navigation. So we run up Zork. West of house. You're standing in an open field west of a white house with a boarded front door. There's a small mailbox. So I'm not going to go through all of Zork at the moment. The writing to the floppy disk isn't working very reliably, and I really need to have a look at that. But until I've got the hard disk working, I don't really want to start trashing any more floppy disks. So we can open mailbox. It says leaflet, read leaflet. Okay, so I'll leave it there. What I've been doing in the background is developing the designs for the IDE disk controller. So next video we'll be covering the IDE disk controller and IDE BIOS. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you can hit like, it just helps to make the videos available to more people. Thanks for watching.